Good evening, students. I hope it is audible and PPT is also visible to you. Just 2 minutes, we will start with the class. So today we are going to start with the next topic, third topic, current electricity. So you already ಹೇಳಿದಿರಾ ಇದಿನ್ನು ಕಂಪ್ಲೀಟ್ ಆಗಿಲ್ಲ ಅಂತ. So we will see step by step all the concepts little detailed. So current electricity li compared to last year ಈ ಸಲ ಏನ್ syllabus deduct ಆಗಿದೆ ಅದರಲ್ಲಿ ಏನೇನ್ ಡಿಲೀಟ್ ಮಾಡಿದ್ದಾರೆ ಅಂತಂದ್ರೆ that is registers in series, registers in parallel derivation ಅನ್ನ ಡಿಲೀಟ್ ಮಾಡಿದ್ದಾರೆ. Then meter bridge, potentiometer, that concept they have deleted. ಅದನ್ನ ಬಿಟ್ಟು ಕಾರ್ಬನ್ ರೆಜಿಸ್ಟರ್ಸ್ ಅಂತ ಕಲಿತೀವಿ. ಸೊ ಕಾರ್ಬನ್ ರೆಜಿಸ್ಟರ್ಸ್ ಅಲ್ಲಿ based on the color code, the resistance of the given carbon register is calculated. That is also deleted. Yes, so these are the deleted part. ಇದನ್ನ ಬಿಟ್ಟು ಕೆಲವೊಂದು sums exercise ಅಲ್ಲಿ ಕೆಲವೊಂದು sums ಅನ್ನ delete ಮಾಡಿದ್ದಾರೆ. Okay, so let us begin with the class. I hope everybody joined. That is Anvita is there. Anvita, Jyoti, Komal, Netravati, Priyanka, Komal. Okay. Yes. So in the current electricity, first we will study what do you mean by current anta kalitivi. Actually current electricity ನೀವು 9th standard ಅಲ್ಲಿ ಕೂಡ ಕಲ್ತಿದ್ದೀರಾ. Sorry, 10th standard ಅಲ್ಲಿ. So 10th standard ಅಲ್ಲಿ current electricity ಕಲಿಬೇಕಾದ್ರೆ ನಿಮ್ಗೆ already electric current ಅಂದ್ರೆ ಏನಂತ ಗೊತ್ತಿದೆ. One minute. Okay, electric current, Ohm's law, voltage, potential difference, resistors in series, resistors in parallel, power calculation. So these all concepts you have studied in the 10th class. So let us see the basic concepts regarding the electric current first. Already first lesson ಅಲ್ಲಿ charge ಬಗ್ಗೆ ಕಲ್ತಿದ್ದೀರಾ. What do you mean by charge? Charge is nothing but it is the fundamental or the intrinsic property of the matter which experiences the electric and the magnetic field. Okay, then next electric current is defined based on the charge here. The electric current is denoted by the letter I. So ನೀವು ಅಲ್ಲಿ formula ಕೂಡ ನೋಡಬಹುದು. The electric current is denoted by I. It is the rate of flow of the electric charge is called as what? Electric current. So in the given interval of time, how many charges will flow through the given conductor? ಆ ರೇಷಿಯೋನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದಾಗ ನಮಗೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಸಿಗತ್ತೆ. ಸೊ I is equal to delta Q by delta T, where limit delta T tends to 0 or dQ by dt ಅಂತ ಹೇಳ್ತಾರೆ. ನಿಮ್ಗೆ ಇದೆಲ್ಲ ಏನು ಬೇಡ ಅಂತಂದ್ರೆ just you remember I is equal to Q divided by T. Okay, so I is equal to Q by T. It is the formula for your electric current. I is equal to Q by T. Then next ನಿಮ್ಗೆ basic properties of the charge ಗೊತ್ತಿದೆ. Charge is quantized ಅಂತ ಹೇಳಿದಾಗ ನಾವ್ ಏನಂತ ಬರಿತೀವಿ? Q is equal to N into E ಅಂತ ಹೇಳ್ತೀವಿ. Therefore electric current I is equal to Q divided by T. So where this Q is equal to, it is N into E divided by T. Howda? Where N is the number of electrons, E is the charge of electron, T is the time interval, correct? So this is current I is equal to Q by T, which is equal to N into E divided by T. So this is the electric current. What is the unit of this electric current? So the formula enide I is equal to Q by T anta ide. So this charge Q anna edrinda heltare, it is expressed in terms of coulomb and time is expressed in terms of seconds. Therefore, it is expressed as coulomb per second anta ಹೇಳ್ತೀವಿ. It is expressed as coulomb per second, or this coulomb per second only it is called as what? Ampere anta ಹೇಳ್ತಾರೆ. Okay, the SI unit of the electric current is ampere. It is denoted by the letter capital A. Correct? Okay. Next, when you can say that the current flowing through the conductor is 1 ampere. So ಯಾವಾಗ ನೀವು 1 ampere ಅಂತ ಹೇಳ್ಬೋದು? ಯಾವಾಗ ನೀವು Q value ಅಂದ್ರೆ charge value 1 coulomb ಅಂತ substitute ಮಾಡ್ತೀರಾ, time ನ 1 second ಅಂತ substitute ಮಾಡ್ತೀರಾ, then the current through the conductor is said to be how much? It is 1 ampere. It is said to be 1 ampere. Yes. So I hope you are understanding. Speed ಆಗ್ತಾ ಇಲ್ಲ ಅಂತ ಅನ್ಕೊಂತೀನಿ. You are understanding. Hope so. So this is the first definition. What is electric current? What is the formula for the electric current? And what is the unit? Now, how you can measure this electric current in the given circuit? So the electric current can be measured with a device called as. So edrinda measure ಮಾಡ್ತಾರೆ? Ammeter ಅನ್ನೋ device ಇಂದ measure ಮಾಡ್ತಾರೆ. So most probably in the colleges you might have started with the experiments. So Ohm's law verification ಒಂದು experiment ಬರುತ್ತೆ, ನೀವು ಮಾಡಿರ್ಬೋದು ಅಂತ ಅನ್ಕೊಳ್ತೀನಿ. The current is measured with a device called as ammeter. If you see all the circuits, ammeters ಯಾವಾಗ್ಲೂ series so even circuit, the ammeters are always connected in the series. I hope this first slide is clear to everyone. So speed ಆಗ್ತಾ ಇದ್ರೆ ಹೀಗೆ ಹೇಳಿ. Okay. Yes. I hope it is clear. I'll go for the next concept. Yes. So you know that there are two types of quantities, a scalar quantity and vector quantity. The current is called as a scalar quantity anta ಹೇಳ್ತಾರೆ. Current is a scalar quantity. Okay. So why current is a scalar quantity? ನಿಮಗೆ ಗೊತ್ತಿದೆ, the current flows from positive terminal of the battery to the negative terminal of the battery. So here you know that the charge always, or the electric current always flows from positive terminal of the battery. So for example, ನೀವು ಏನಾದರೂ simple ಆಗಿ ಒಂದು circuit consider ಮಾಡಿದ್ರೆ, so this is a battery and battery positive terminal, battery negative terminal ಅಂತ ಏನಾದರೂ ನೀವು consider ಮಾಡಿದ್ರೆ, here always the current flows from positive terminal of the battery to the negative terminal of the battery. ಆಯ್ತಾ? Even though it is having direction. So ನೀವು ಇಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾ ಇದ್ದೀರಾ, the current is having, or it is having the direction of positive terminal to the negative terminal of the battery. So ನೀವು ಈ ತರ ಹೇಳಿದ್ರು ಕೂಡ why current is a scalar quantity. Yes. So ನಿಮಗೆ ಗೊತ್ತಿದೆ, when any quantity is having both magnitude and the direction, the quantity is said to be a quantity. ಮತ್ತೆ ಯಾಕೆ ನಾವಿಲ್ಲಿ ಸ್ಕೇಲಾರ್ ಅಂತ ಹೇಳ್ತಿದೀವಿ? ಯಾರಿಗಾದ್ರೂ ಏನಾದ್ರೂ ಐಡಿಯಾ ಇದೆಯಾ? So if you interact, if you know anything, you can discuss. Yes, girls, anybody knows?
Does not follow vector law of addition.
Yes, yes. So here, whatever the current is there, it will not obey the vector laws of addition. Aita? So here, vector anta ನೀವು ಯಾವುದೇ quantity ಅನ್ನು describe ಮಾಡಬೇಕಾದ್ರೆ, that quantity should agree the vector addition laws. Okay, vector addition, vector subtraction laws ಅಲ್ಲಿ satisfy ಆಗಬೇಕು. But here a scalar quantity is not obeying, sorry, the electric current is not obeying that vector addition laws. Therefore, it is a scalar quantity even though it is having a direction. ಮತ್ತೆ ಇದು ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಆಗ್ತಾ ಇಲ್ಲ, ಹೌದಾ? ಸೊ ನೀವು ವೆಕ್ಟರ್ ಕ್ವಾಂಟಿಟೀಸ್ ಅಂತ ಹೇಳ್ಬೇಕಾದ್ರೆ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಚೇಂಜ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ನಮ್ಗೆ ಯಾವ ತರ ಬೇಕೋ ಆ ತರ ಚೇಂಜ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಆ ಕ್ವಾಂಟಿಟಿಯನ್ನ ನಾವು ವೆಕ್ಟರ್ಸ್ ಅಂತ ಹೇಳ್ಬೋದು. ಬಟ್ ಇಲ್ಲಿ ಇಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ನಮ್ಗೆ ಯಾವ ರೀತಿಯಾಗಿ ಬೇಕೋ ಆ ರೀತಿಯಾಗಿ ಶಾರ್ಟ್ ಕಟ್ ರೂಟ್ ಫಾಲೋ ಮಾಡೋದಾಗ್ಲಿ, it is not having any shortcut or any different directions for different circuits. So ella circuit allu it will travel from the positive terminal of the battery to the negative terminal of the battery. Yes. So ನಾನು ಇದು ಕೆಳಗಡೆ ಇದ್ದದನ್ನ ಆಲ್ರೆಡಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀನಿ. I'll go for the next slide. Yes. So here we have one definition that is called as the current density. So what is this current density? Current density is denoted by the letter J, and this current density is defined as it is the current per unit area. The current density is defined as current per unit area. It is called as what? Current density. Yes. J is equal to I divided by A. What is the unit? So current density adrinda express ಮಾಡಬಹುದು. ಇಲ್ಲಿ ನೋಡಿ current by area ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. So current is taken as ampere and the area is taken as meter square. So ampere per meter square is the unit of your current density. So you will note that here it is I is equal to J dot dA. It is dot product. So when it is a dot product, we can write it as J dA cos theta. We can write it as J dA cos theta. Correct? So this is regarding the current density. So first we have studied what is electric current. Then regarding electric current, the direction of the electric current, the unit of the electric current, the device to measure the electric current. Next point, the electric current density. So it is denoted by J. It is the ratio of current by area. Next. See, electric current is a scalar quantity, but the current density is a vector quantity. So current density ಅನ್ನೋದೇನಿದೆ ಇದು vector quantity ಆಗಿದೆ, ಆಯ್ತಾ? The flow of electric charge in a metallic conductors among the solids, all the metals are good conductors of electricity. The reason is what? Because it consists of a free electrons. So ella conductors it is a good conductor of electricity. Why? Because all metals are good conductors of electricity because it is having the free electrons. So free electrons ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ it is a good conductor of electricity ಅಂತ ನಾವಿಲ್ಲಿ ಹೇಳ್ಬೋದು. Next. So here that is in case of a solid conductor ಅಂದ್ರೆ copper, iron, silver atoms are tightly bound to each other. There are large number of free electrons in them. So solid conductors ಅಲ್ಲಿ ಇದು ಸ್ವಲ್ಪ standard examples ಅಂತ ಹೇಳ್ಬೋದು. For wire making and all we can use these metals. Then in the liquid conductors like electrolytic solutions, there are positive and the negative charged ions which can move on applying electric field. Okay, so this is regarding the flow of charges in a conductor and in a liquid conductor. Then the next point is that is drift velocity. So drift velocity ಅಂತಂದ್ರೆ ಏನೀಗ? So for example, ಈಗ assume ಮಾಡಿ you have any one conductor here. Yes. So consider I have one conductor. It is connected to the battery. So when it is connected to the battery, you know that from the positive terminal of the battery to the negative terminal of the battery, the charge is flowing through across this conductor. ಹೌದಾ? Next ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ? Here, when I subject this conductor or this system for the external electric field. So suppose I have any one conductor, ನೀವು circuit connection ಮಾಡಿಲ್ಲ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ನೀವೇನ್ ಮಾಡಿ, ನಿಮ್ಮ ಹತ್ರ ಯಾವುದೋ ಒಂದು ಕಂಡಕ್ಟರ್ ಇದೆ. ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ? ಕಂಡಕ್ಟರ್ಸ್ ಅಂದ್ರೆ ಮೆಟಲ್ಸ್ ಅಂತ ತಗೊಳ್ಳೋಣ. So metals ಅಲ್ಲಿ free electrons ಇರುತ್ತೆ. Whatever this free electrons it is there, these free electrons are moving randomly. These free electrons are moving randomly when it is subjected to the external electric field. So ಇದನ್ನ ಯಾವಾಗ ನಾವು external electric field ಗೆ ಇಡ್ತೀವಿ ಅವಾಗ ಏನಾಗತ್ತೆ ಅಂತಂದ್ರೆ here the electrons will get drifted. Drifted ಅಂತ ಅಂದ್ರೆ ಏನ್ ಗೊತ್ತಾ? Drifted ಅಂತ ಅಂದ್ರೆ accelerated ಅಂತ ನಾವು ಹೇಳ್ಬೋದು. The electrons will get accelerated to some velocity. So that velocity is called as what? Drift velocity. So drift velocity ಅಂತಂದ್ರೆ ಏನು? It is a particular velocity when the electrons will get drifted or the electrons will get accelerated in the electric field is called as drift velocity. So il definition ide: average velocity with which the free electrons move towards the positive end of the conductor under the influence of an external electric field applied. ನಿಮ್ಗೆ ಏನಾದ್ರು ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ ಆಯ್ತಾ. ಸೊ ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಅರ್ಥ ಆಯ್ತು ಅಂತ ಅನ್ಕೊಳ್ತೀನಿ. You can assume that when external electric field is applied, the electrons will get drifted with some velocity, and that is called as what? Drift velocity. That is called as drift velocity. Yes, next. Then the next point, here the drift velocity is given by, it is denoted by VD. So formulas ಅನ್ನ denote ಮಾಡ್ತಾ ಹೋಗಿ, ಅಂದ್ರೆ ನಮಗೆ numerical solve ಮಾಡ್ಬೇಕಾದ್ರೆ easy ಆಗುತ್ತೆ. Drift velocity is denoted by VD, which is equal to E into E upon M into tau. E ಅಂದ್ರೆ ಇಲ್ಲಿ ನೋಡಬಹುದು ಎಲ್ಲ symbols explain ಮಾಡುತ್ತಿದೆ. Small e is the charge of the electron, capital E is the electric field, M is the mass of that particle, ಯಾವ particle ಕೊಟ್ಟಿರ್ತಾರೆ ಅದರದ್ದು. So it is relaxation time. So what is relaxation time? We will discuss. So first drift velocity ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, then drift velocity expression. So till now we have covered three formula, girls. That is, first one, the electric current, basic definition. So ಯಾರು ಬರ್ಕೊಂಡಿಲ್ಲ ನೀವು ಈಗ ಬೇಕಾದ್ರೆ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಳ್ಳಿ. Electric current is equal to charge upon time. Then the quantization of charge ಪ್ರಕಾರ ಇದನ್ನ Ne upon T ಅಂತ ಮಾಡ್ತೀವಿ. So this is first formula. Second formula, the current density is equal to current per unit area. Current density is equal to current per unit area. Okay. Then the third point, third formula for this slide, it is drift velocity is equal to E into E upon M into tau. So E is the charge of the electron, capital E is the electric field, M is the mass, tau is the relaxation time. Yes. So drift velocity. So ನೀವು ಏನಾದರೂ values calculate ಮಾಡಿದಾಗ ಇಲ್ಲಿ ಏನು ಆನ್ಸರ್ ಬರುತ್ತೆ, it should be expressed in the meter per second. Meter per second. So ನಾವೀಗ relaxation time ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ವಿ. So what is relaxation time? If you consider a conductor, so ನೀವು ಯಾವ್ದಾದ್ರು ಕಂಡಕ್ಟರ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ, in this conductor whatever the electrons are there, so these electrons, when it is moving randomly, the time interval between any two electrons collision, the time interval between any two electrons collision is called as what? Relaxation time. It is the time interval between the collision, two successive collision of the electrons is called as relaxation time. So ಯಾವ್ದಾದ್ರು ಪಾಯಿಂಟ್ ರಿಪೀಟ್ ಬೇಕಾದ್ರೆ ಹೇಳಿ. So relaxation time, drift velocity, current density, electric current. Now you can see the drift velocity of electron is of the order of 10 to the power of -4 meter per second ಅಂತ ಬರುತ್ತೆ ಆಯ್ತಾ. Now we know drift velocity, we know electric current, we know current density. Then what is the relation between this current density and the drift velocity, or what is the relation between the electric current and the drift velocity? Let us see here. So here the current density at any point in the conductor is given by, so ಇಲ್ಲಿ current density, now basic expression ಏನು ನೋಡಿದ್ವಿ, current density is equal to I upon A anta nodidvi. Here we have one more formula for this current density, that is J is equal to NE VD. It is J is equal to NE VD. So this is what the current density is equal to. So ನೀವು ಇದನ್ನ current ಅಂತ ಬೇಕಾಗಿದ್ರೆ it will come I is equal to NEA VD ಅಂತ ಬರುತ್ತೆ. ಸೊ ಯಾವಾಗ ನಾನು ಇಲ್ಲಿ A denominator ಅಲ್ಲಿ ತಗೊಂತೀನಿ I by A NEVD ಆಗುತ್ತೆ. ಸೊ I by A ಅಂದ್ರೆ ಏನು girls? That is nothing but the current density. ಹೌದಲ್ಲ? ಅರ್ಥ ಆಯ್ತಾ? ಸೊ ಡೆರಿವೇಶನ್ಸ್ ಏನ್ ನಾವು ಇಲ್ಲಿ ನೋಡ್ತಾ ಇಲ್ಲ, ಡೆರಿವೇಶನ್ ಸಿಂಪಲ್ ಆಗಿದೆ. ನಿಮ್ಗೆ ಯಾವ್ದಾದ್ರು ಡೆರಿವೇಶನ್ ಬೇಕಂದ್ರೆ we will discuss. So current density and the current and the drift velocity relation. That is I is equal to NEAVD and current density J is equal to NEVD. N is number of electrons, E is charge of electron, VD is the drift velocity. I hope it is clear. Okay. Next. Here we are defining next quantity, that is called as the mobility. So what is this mobility? Mobility and the mu in the denote ಮಾಡ್ತಾ ಇದೀವಿ. So mobility is denoted by mu here. What is mobility? Let us see. So mobility, it is the ratio of drift velocity of the electron and the applied electric field is known as what? Mobility. So you will note mobility is equal to mu is equal to drift velocity upon the applied electric field. VD upon E. This is called as mobility anta ಹೇಳ್ತಾರೆ. Here this drift velocity or the mobility is also expressed in terms of. So the mobility enna mattondu unit mattondu expression ಏನಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, mu is equal to it is q into tau divided by m. Q into tau divided by m. So q is the charge, tau is the relaxation time, m is the mass. Yes, note down the formulas. Don't miss any formula. So ಈ ಲೆಸನ್ ಅಲ್ಲಿ ಬಹಳ ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ. So ಒಂದೊಂದಾಗಿ ನೋಟ್ ಡೌನ್ ಮಾಡ್ತಾ ಹೋಗಿ, it will be easy for us to solve the MCQs. Now here actually SI unit ಅಂತ ಹೇಳಿದ್ದಾರೆ, that SI unit is meter square per second per volt. So meter square per second per volt is the unit of your mobility. Okay? So unit also you note down. Next. Next one, that is Ohm's law. So what is Ohm's law? Already in the 10th class you people have studied. So yaradru bekadre define ಮಾಡಬಹುದು. Anybody is interested? The statement of Ohm's law.
At constant temperature, current passing through the conductor is directly proportional to the voltage difference.
Yes. Okay, very good. So see here, that is the electric Ohm's law is giving the relation. Now what is electric current anta nodidvi. Actually one more here, that is electric potential. So what is electric potential? Electric potential means, last lesson al now already electric potential la nodidvi. The electric potential is defined as, it is work done per unit charge. So this is called as what? Electric potential. So if you are doing the work done between the two different points A and B, then this potential is given by VA minus VB. Correct? So this is what voltage or the potential anta ಹೇಳ್ತೀವಿ. So till now we have discussed about the electric current and the potential. Now what is the relation between this electric current and the potential? So the relation between electric current and the potential is given by, it is I is directly proportional to V. I is directly proportional to V. So here one condition we will specify. In condition andre at constant temperature anta ಹೇಳ್ತೀವಿ, at constant temperature. So how you can define the Ohm's law here? At constant temperature, the electric current is directly proportional to the applied voltage. Correct? Now, to remove the proportionality sign, we take a constant here, and that constant is I is equal to, sorry, V is equal to I into R. This V is equal to I into R, where this R is called as resistance. R ಅನ್ನ resistance ಅಂತ ಕರೀತಾರೆ ಆಯ್ತಾ. ನೀವು ಇಲ್ಲಿ resistance ಅನ್ನ R is equal to V by I ಅಂತ ಕೂಡ ಬರೀಬಹುದು. Resistance is written as R is equal to V by I. So V is the potential, I is the electric current. So V by I is the resistance here. Correct? Then what is the unit of this resistance? So the unit of resistance, so with respect to the scientist, the unit is named here. Unit of the resistance is given by ohm. This is given by, and the symbol is, you can see. So maths alli ನೀವು ಬೇಕಂದ್ರೆ omega denote ಮಾಡ್ತೀರಾ. So this is regarding the Ohm's law. Yes. So once again, I am revising. First, we discussed about the electric current. Then we discussed about the current density. After that, we have discussed about the drift velocity. Then after that, the mobility. Then the next one, relaxation time. So drift velocity, relaxation time. Here mobility discuss ಮಾಡಿದ್ವಿ. So mobility ಆದ್ಮೇಲೆ we are discussing the relation between V and I with the help of the Ohm's law, and it is given by V is equal to IR. So this many points we have like that. Next. The next point. So no effect of V and I on R, because as V increases, I decreases, but R remains the same. Yes. So here, whatever the resistance is there, it is not depending on your V and I. V ಮತ್ತೆ I ಮೇಲೆ depend ಆಗಿಲ್ಲ ಆಯ್ತಾ. Your resistance is depending on some other factors only. So resistance ಎದ್ರ ಮೇಲೆ depend ಆಗಿದೆ. Here the resistance of a given conductor, it is depending on. So ನಾವೀಗ first ಅಂತೂ ಏನ್ ಹೇಳಿದ್ವಿ, it is depending on the temperature. So why it is depending on the temperature? ಏನಾಗತ್ತಂತ ಅಂದ್ರೆ temperature increase ಆದಾಗ in a conductor, whatever the electrons are there, so its motion will affect. So temperature ಹೆಚ್ಚಾದಾಗ ಏನಾಗುತ್ತೆ, ಇದ್ರದ್ದು motion ಹೆಚ್ಚು ಕಡಿಮೆ ಆಗುತ್ತೆ. Because of that reason, the resistance value will vary here. So it is depending on the resistance. Then the resistance of a given conductor, it is depending on the length also. So length of the conductor ಮೇಲೆ depend ಆಗಿರುತ್ತೆ. ಯಾವ ರೀತಿಯಾಗಿ depend ಆಗಿರುತ್ತೆ ನೋಡಿ. For example, if you have any one conductor of length L, so this is one more conductor of the same thickness. This is of the length L2. So L1, L2 ಅಂತ ನಾವಿಲ್ಲಿ consider ಮಾಡೋಣ. Okay, so when you have two different wires of different length, where the electric current will be more. So L current ಜಾಸ್ತಿ ಇರುತ್ತೆ, where the electrons will be more, where the charges will be more. So ಎರಡರದ್ದು length ಅಲ್ಲಿ L2 length ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ the number of electrons will be more. ಹೌದಾ? So when the number of electrons will be more, automatically the electric current will also be more here. Correct? So current ಜಾಸ್ತಿ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, resistance value ಇಲ್ಲಿ ನೋಡಿ, we have V equal to I into R. Therefore, I is equal to V by R. So ನಿಮ್ಗೆ ಈ ತರ ಬರ್ಬೇಕು ಗೊತ್ತಾಗತ್ತೆ ಅಂತ ಅನ್ಕೊಳ್ತೀನಿ. Here the current is in the numerator, the resistance is in the denominator. So resistance value is increasing, the current value is decreasing. The current value is increasing, the resistance value is decreasing. Here, as the length is more, obviously the current will be more. So when the current is more, the resistance value is decreasing. So therefore, here the resistance and the length are directly proportional with each other. So here actually one more point we can discuss here, that is nothing but why one by one is leaving the session. Theory ಬೇಡ ಅಂದ್ರೆ ನಾವು numerical ಗೆ ಹೋಗೋಣ, ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. Yes, hope so you require theory also.
Yes, ma'am. Theory
Okay. So see what we were discussing, that is okay. So I'll give here 4 diagrams I'll give. So this is one length L, and one more I have little bit bigger one. This is second wire of the length L2. Then I have 2 wires, 2 more wires. One is having area this much and the other one is having area more. Yes. So now compared to length. So when this is first length, this is L1, this is L2, and this is A1, this is my A2. Okay, first length ಬಗ್ಗೆ ನೋಡೋಣ. As I told you, the electrons will be more. No doubt the electrons will be more when the length is more. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಕರೆಂಟ್ ಹೆಚ್ಚಾಗತ್ತೆ ಅಂತ ಹೇಳಿದ್ವಿ. ಬಟ್ ಇಲ್ಲಿ ಮತ್ತೊಂದು ಫ್ಯಾಕ್ಟರ್ ಅಫೆಕ್ಟ್ ಆಗುತ್ತೆ. ಏನ್ ಹೇಳಿ? ಸೊ ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಏರಿಯಾ ಏನ್ ಜಾಸ್ತಿ ಇಲ್ಲ, ಹೌದಾ? ಸೊ ವೆನ್ ದ ಏರಿಯಾ ಇಸ್ ನಾಟ್ ಮೋರ್, electrons ಏನಾಗುತ್ತೆ, collision ಆಗುತ್ತೆ. The between the electrons collision takes place. So when the collision takes place, loss of energy ಆಗುತ್ತೆ. So loss of energy ಆದಾಗ ಏನಾಗುತ್ತೆ, automatically the current value decreases. Actually ನಮಗೆ ಯಾವ ತರ ಅನ್ಸುತ್ತೆ, the length is more, therefore the electrons will be more, therefore the current will be more. But that is not the truth here. Here what is happening here, as the length is increasing but area is not increasing, the electrons will collide with each other. So when the electrons will collide with each other, loss of energy takes place. Due to the loss of energy, the current value decreases. So when the current value decreases, the resistance value increases. Therefore, now I can write R is proportional to L. I hope why R is proportional to L, it is clear to you. So you just remember that as the length increases, the resistance also increases. What happens in case of the area? So ಇಲ್ಲಿ ನೋಡಿ, area ಎರಡು ಬೇರೆ ಬೇರೆ ಇದೆ. So first figure ಅಲ್ಲಿ ಮತ್ತೆ second figure ಅಲ್ಲಿ, whatever the area it is there, A2 area ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ, A2 area ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ electrons are free to move. So free to move ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ, energy loss ಕಡಿಮೆ ಆಗುತ್ತೆ, ಹೌದಾ? So energy loss ಕಡಿಮೆ ಆದಾಗ ಏನಾಗುತ್ತೆ, the current value will be more. According to your V is equal to IR expression. So when the current is more, what about the resistance? The resistance is decreasing. So therefore, I can say that the resistance is inversely proportional to the area. The resistance is directly proportional to the length and it is inversely proportional to the area. Okay. We can combine these two. That is R is proportional to L, R is proportional to inversely proportional to A. So it is R is proportional to L upon A. Therefore, we can write it as proportionality sign ತೆಗೆದು equal sign ತಗೋಬೇಕಾದ್ರೆ ನಾವು ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ರೋ ಅಂತ ತಗೊಂತೀನಿ. It is rho L divided by A. So R is equal to, it is rho L divided by A. So therefore, I am introducing the new term to you, that is the rho. This rho is called as resistivity ಅಂತ ಹೇಳ್ತಾರೆ. This rho is called as resistivity of the wire. Yes, therefore rho is equal to R into A divided by L. So note down the next formula. So one R is equal to rho L upon A ಅಂತ ಕೂಡ denote ಮಾಡ್ಕೊಳ್ಳಿ. One more is rho is equal to R into A upon L ಅಂತ ಕೂಡ denote ಮಾಡ್ಕೊಳ್ಳಿ. Let us see what is the unit now. The resistance is expressed in terms of ohm. Area is expressed in terms of meter square. Length is expressed in terms of meter. So meter will get cancelled. We have ohm meter. So ohm meter is the unit of what? Resistivity. Ohm meter is the unit of resistivity. So I hope formula and the unit you have noted down. Next. Okay. Now, how to define this resistivity? So I have R is equal to rho into L upon A, or I have rho is equal to R into A upon L. How I can define this resistivity? See, I'll write R is equal to A rho, or rho is equal to R. So what is the meaning here? Length is 1 meter, area is 1 meter square, then 1 upon 1, it is nothing but R here. Therefore, the resistivity is nothing but the resistance. But when the length of the conductor is 1 meter and its area is 1 meter square. correct? The length of the conductor is 1 meter and its area is 1 meter square, then the resistivity is said to be the resistance. So how you can define the resistivity? Resistivity is nothing but the resistance of the conductor when the area is 1 meter square and the length is 1 meter. Then the resistivity is said to be resistance itself. So here, suppose in the exam, if they are asking you the factors affecting the resistance, ನೀವೇನ್ ಬರಿತೀರಾ? The resistance is depending on temperature, nature of it is depending on the length, it is depending on the area. But resistivity ಯಾವುದು ಫ್ಯಾಕ್ಟರ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿಲ್ಲ. ಯಾಕೆ ಹೇಳಿ? Because the resistivity value is constant for a given material. So resistivity ಅನ್ನೋದು ಏನಿರುತ್ತೆ? Constant ಇರುತ್ತೆ. If you consider copper, the resistivity value is constant. If you consider iron, if you consider silver, if you consider gold, so ನೀವು ಯಾವುದು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಅದ್ರದ್ದು resistivity value ಏನಿರುತ್ತೆ? Constant ಇರುತ್ತೆ. So it will not vary for the, it will vary for material to material, but the value is constant here. ಅರ್ಥ ಆಯ್ತಾ? So resistivity does not depend on any factor, but the resistance depends on these 4 factors. So keep it in your mind. So ಇಲ್ಲಿ ಕ್ವಶನ್ ಯಾವ ತರ ಬೇಕಾದ್ರೂ ಟ್ವಿಸ್ಟ್ ಮಾಡಬಹುದು. ಸೊ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಸ್ವಲ್ಪ ಕ್ಲಿಯರ್ ಆಗಿ ಗೊತ್ತಿರಲಿ. So this already we have defined the relation between resistivity and relaxation time ಕೊಟ್ಟಿದ್ದಾರೆ. So you can see the resistivity and the relaxation time, it is given by, I hope the formula is visible to you. That is resistivity rho is equal to m upon n e square into tau, where m is the mass, n is the number of electrons, e is the charge of electron, tau is the relaxation time. So the resistivity rho is equal to m upon n e square into tau. So this resistivity, it is also called as the specific resistance anta kuda ಹೇಳ್ತಾರೆ. It is also called that specific resistance. It depends on the material of the conductor, not on the length, cross section and the geometry of the conductor. ಅಂದ್ರೆ shape ಆಯ್ತು, length ಆಯ್ತು, area ಆಯ್ತು, ಎದ್ರ ಮೇಲೂ ಡಿಪೆಂಡ್ ಆಗಿಲ್ಲ. It is depending only on the what? Material of the conductor. That is R is equal to rho L upon A. Next. Here one expression they have given. So that is percentage change in the resistance. You just the formula note down ಮಾಡ್ಕೊಳ್ಳಿ. That is delta R by R into 100 is equal to delta L by L into 100 minus delta A by A into 100. So first year ಅಲ್ಲಿ you have studied errors C. So combination of errors ಕಲಿಬೇಕಾದ್ರೆ ನಾವು ಇದನ್ನ ಕಲ್ತಿದೀವಿ. So delta L, delta A, delta R is the increase or the change in the values. So this is percentage change in the resistance ಅಂತ ಹೇಳ್ತೀವಿ. So just formula note down ಮಾಡಿ, when we are solving it, we can discuss this formula. Okay, then the next, that is temperature coefficient of resistance, it is given by. So here again we have the list of formulas. That is the change in the resistance per ohm for a change in the temperature of T degree Celsius from 0 degree Celsius is called temperature coefficient. So ನಾನು ನಿಮಗೆ ಫಾರ್ಮುಲಾನೇ ಡೈರೆಕ್ಟ್ ಆಗಿ ಹೇಳ್ತೀನಿ. That is this temperature coefficient is letter alpha. So temperature coefficient ಅನ್ನ alpha ಇಂದ ಡಿನೋಟ್ ಮಾಡ್ತಾರೆ. So this alpha is nothing but what? That is change in the resistance per ohm for the change in the temperature from T degree Celsius to 0 degree Celsius. Okay, so this is called as what? Temperature coefficient at 0 degree Celsius ಅಂತ ಹೇಳ್ತಾರೆ. So definition is important ಇಲ್ಲ. So formula ನೋಡಿ, that is RT minus R naught is proportional to R naught. RT minus R naught is proportional to R naught. This RT minus R naught also proportional to delta T. RT minus R naught ಅಂತ ಅಂದ್ರೆ change in the resistance value ಎದಕ್ಕೆ proportional ಆಗಿರುತ್ತೆ? The resistance at the 0 degree Celsius proportional ಆಗಿರುತ್ತೆ. Again the change in the resistance value ಎದಕ್ಕೆ proportional ಆಗಿರುತ್ತೆ? That is for the temperature it is dependent. So now we can write it as RT minus R naught is proportional to delta T into R naught. Delta T into R naught. So ಇದೆಲ್ಲ proportionality sign ಆಯ್ತಾ? Don't get confused. Now I am removing and taking the equal sign. So ನನಗೆ equal sign ತಗೋಬೇಕಾದ್ರೆ ಇಲ್ಲೊಂದು proportionality constant ತಗೊಳ್ಬೇಕಾಗತ್ತೆ. That is my alpha. So this is first, second, third equation ಅಲ್ಲಿ ಅದು proportional sign ಇದೆ. Fourth ಅಲ್ಲಿ that is alpha. So this alpha is called as what? Coefficient of or the temperature coefficient ಅಂತ ಹೇಳ್ತಾರೆ. So it is alpha delta T into R naught. So this is RT minus R naught is equal to. What I'll do, ನಾನೀಗ RT is equal to ಬರ್ಕೊಳ್ತೀನಿ. R naught minus ಇದೆ, ಈ ಕಡೆ ಬಂದಾಗ R naught plus alpha delta T into R naught. So ಇಲ್ಲಿ ನಾವು ಏನ್ ಹೊರಗೆ ಬರುತ್ತೆ? R naught ಕಾಮನ್ ಇದೆ. So R naught into bracket 1 plus alpha delta T. So this is my RT is equal to formula. RT is equal to R naught into bracket 1 plus alpha delta T, where alpha is the temperature coefficient, delta T is the change in the temperature. So ನಿಮ್ಗೆ exam ಅಲ್ಲಿ ಅಥವಾ question ಅಲ್ಲಿ change in the temperature ಕೊಟ್ಟಿದ್ರೆ you can change this delta T as T minus T naught ಅಂತ ಕೂಡ ಬರಿಬಹುದು. Delta T can be written as T minus T naught. Correct? So this is the temperature coefficient of the resistance. So ಇಲ್ಲಿ resistance ಮೇಲೆ ಐತಿ ಫಾರ್ಮುಲಾ. ನೀವು ಇದೇ ಫಾರ್ಮುಲಾನ ಇಲ್ಲಿ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಳ್ಳಿ. ದ ಸೇಮ್ ಫಾರ್ಮುಲಾ ಕ್ಯಾನ್ ಬಿ ರಿಟನ್ ಫಾರ್ ದ ದಟ್ ಇಸ್ ರೆಸಿಸ್ಟಿವಿಟಿಗೂ ಬರಿಬಹುದು. ಇಟ್ ಇಸ್ ರಿಟನ್ ಆಸ್ rho T is equal to, so rho T, not eating roti, that is rho resistivity with respect to the temperature T in rho is equal to rho naught into bracket 1 plus alpha delta T ಅಂತ ಕೂಡ ಬರೀತಾರೆ ಆಯ್ತಾ. So this is what? This is resistivity formula and that is the resistance formula. At 0 degree Celsius and at T degree Celsius. So ಕೆಲವೊಂದ್ಸಲಿ 0 ಡಿಗ್ರಿ ಮತ್ತೆ T ಡಿಗ್ರಿ ಅಂತ ಕೊಡಲ್ಲ. ಕೆಲವೊಂದ್ಸಲಿ ಏನ್ ಮಾಡ್ತಾರೆ, ಒಂದ್ ಲೋವರ್ ಟೆಂಪರೇಚರ್ ಕೊಟ್ಟಿರ್ತಾರೆ, ಒಂದ್ ಹೈಯರ್ ಟೆಂಪರೇಚರ್ ಕೊಟ್ಟಿರ್ತಾರೆ. ಸೊ ನೀವು ಅದ್ರ ಪ್ರಕಾರ ಅಲ್ಲಿ ಫಾರ್ಮುಲಾನ ಚೇಂಜ್ ಮಾಡಬಹುದು. So don't stick to the mind that is it is 0 degree Celsius and T degree Celsius. ಕೆಲವೊಂದ್ಸಲಿ ಬೇರೆ ಬೇರೆ ಟೆಂಪರೇಚರ್ ವ್ಯಾಲ್ಯೂಸ್ ಕೂಡ ಕೊಡ್ತಾರೆ ಅವರು ಆಯ್ತಾ. ಅಗೇನ್ ಇಲ್ಲೇನ್ ಅಲ್ಫಾ ಇದೆ, ದಿಸ್ ಅಲ್ಫಾ ಇಟ್ ಇಸ್ ಎ ಕಾನ್ಸ್ಟಂಟ್. ಸೊ ರೆಸಿಸ್ಟಿವಿಟಿ ಯಾವ ತರ ಕಾನ್ಸ್ಟಂಟ್ ಇತ್ತಲ್ಲ ಫಾರ್ ಅ ಮಟೀರಿಯಲ್, ದ ಅಲ್ಫಾ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಆಲ್ಸೋ ಕಾನ್ಸ್ಟಂಟ್ ಅಂತ ಹೇಳ್ತಾರೆ ಆಯ್ತಾ. ದಿಸ್ ಅಲ್ಫಾ ವ್ಯಾಲ್ಯೂ ವಿಲ್ ವೇರಿ ಫ್ರಮ್ ಮಟೀರಿಯಲ್ ಟು ಮೆಟೀರಿಯಲ್. ಸೊ ಆಕ್ಚುಲಿ ನಾವು ಎರಡ್ ತರ ಕಾನ್ಸ್ಟಂಟ್ ಹೇಳ್ಬೋದು ಯಾವಾಗ್ಲೂ ಫಿಸಿಕ್ಸ್ ಅಲ್ಲಿ. ಒಂದು ಯೂನಿವರ್ಸಲ್ ಕಾನ್ಸ್ಟಂಟ್ ಇರುತ್ತೆ, ಮತ್ತೊಂದು ಇಟ್ ವಿಲ್ ವೇರಿ ಫ್ರಮ್ ಮಟೀರಿಯಲ್ ಟು ಮಟೀರಿಯಲ್ ಬಟ್ ದ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಕಾನ್ಸ್ಟಂಟ್ ಫಾರ್ ದ ಮಟೀರಿಯಲ್. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? For example, acceleration due to gravity, how much it is? It is 9.8 meter per second square. The speed of the light in the vacuum, 3 into 10⁸ meter per second. Then the value of capital G, it is 6.627 into 10⁻⁻11. Correct. So this is capital G value. Same way the Planck's constant, Rydberg constant, gas constant. Yes. So these are all what? Universal constant. And there is material to material. ನಾವೇನ್ ರೆಸಿಸ್ಟಿವಿಟಿ ಅಂತ ಹೇಳಿದ್ವಿ, ಇಟ್ ಇಸ್ ಚೇಂಜಿಂಗ್ ಫ್ರಮ್ ಮಟೀರಿಯಲ್ ಟು ಮೆಟೀರಿಯಲ್. ಇಲ್ಲೇನ್ ನಾವು ಕೋಯಿಫಿಷಿಯಂಟ್ ಆಫ್ ಟೆಂಪರೇಚರ್ ಅಂತ ರೆಸಿಸ್ಟೆನ್ಸ್ ಟೆಂಪರೇಚರ್ ಅಂತ ಹೇಳ್ತಿದೀವಿ, ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಕಾನ್ಸ್ಟಂಟ್ ಫಾರ್ ದ ಮಟೀರಿಯಲ್ ಟು ಮಟೀರಿಯಲ್. ಇದೇ ತರ ಫಸ್ಟ್ ಇಯರ್ ಅಲ್ಲಿ ಯಂಗ್ಸ್ ಮಾಡ್ಯುಲಸ್ ಕಲ್ತಿದ್ದೀರಾ, ಬಲ್ಕ್ ಮಾಡ್ಯುಲಸ್ ಕಲ್ತಿದ್ದೀರಾ. So these all values are what? Constant, but constant for the given material. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? So don't get confused with the constants here. Clear? So ಇಲ್ಲಿವರೆಗೆ ಯಾರಿಗೇನಾದ್ರೂ ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಅಂದ್ರೆ you can ask. Otherwise one point we will discuss and we will stop it. So ಯಾರಿಗಾದ್ರೂ ಏನಾದ್ರು ತಿಳಿಲ್ಲ ಮಾಡ್ಲಿಕ್ಕೆ ಇರ್ಬೋದು. I hope you have taken down all the formulas till now whatever we have discussed. So ಇದರಲ್ಲಿ RT is equal to ಇದೊಂದು ಫಾರ್ಮುಲಾ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಳ್ಳಿ. Then rho T is equal to ಇದೊಂದು ಫಾರ್ಮುಲಾನ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಳ್ಳಿ ಆಯ್ತಾ. Just recall the concepts. ಯಾವ್ದಾದ್ರು repeat ಬೇಡ ಅಂದ್ರೆ we will see one more point and we will stop it. Yes, tell me in the chat box, you can tell. One more point we will discuss. Any doubt, any formula repetition, anything? Okay, if you don't reply, I will go for the next one. Oh, yes. Okay. So while defining this resistivity, one more point forgot to tell you, that is regarding conductivity. So here, you know till now what is resistance. So resistance ಅಂದ್ರೆ ನಿಮ್ಗೆ ಎಲ್ಲರಿಗೂ ಗೊತ್ತಿದೆ ಈಗ. It is nothing but what? V divided by I. The opposition to the flow of current is called as the resistance. Here, the reciprocal of this resistance is called as, so R is equal to 1 upon C or C is equal to 1 upon R. This is called as conductance anta ಹೇಳ್ತಾರೆ. It is called as conductance. So what is conductance? The reciprocal of resistance is called as the conductance. Same way, the reciprocal of resistivity, it is called as conductivity. So conductance, conductivity. So the reciprocal of resistance is conductance, the reciprocal of resistivity is conductivity. ಆಯ್ತಾ? ಸೊ ಇಲ್ಲಿ ಯೂನಿಟ್ ಆಗತ್ತೆ ನೋಡಿ, ದ ರೆಸಿಪ್ರೋಕಲ್ ಆಫ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಂತ ಹೇಳ್ತಿದೀವಿ. ಸೊ ರೆಸಿಸ್ಟೆನ್ಸ್ ಯೂನಿಟ್ ಓಮ್ ಇತ್ತು, ಇದು MHO ಮೂ ಅಂತ ಆಗತ್ತೆ, ಅಥವಾ ಬರಿಬೇಕಾದ್ರೆ ಈ ತರ ಬರೀತಾರೆ. ದಟ್ ಇಸ್ ಫಾರ್ ದ ಕಂಡಕ್ಟನ್ಸ್. Similarly for the conductivity, so for resistivity it is ohm meter. So reciprocal ಏನಾಗತ್ತೆ per ohm per meter. This is regarding the conductivity. So you can take down these 2 points also. Now, whatever the formulas we have discussed, that is the current density and all, we can express it in terms of this conductivity also. That is, note down, the current density is given by, that is J is equal to, in terms of conductivity it is sigma into E. Sigma anta andre conductivity. So the current density in terms of conductivity it is given by sigma into E, where E is the electric field, sigma is the conductivity, J is the current density. So this formula also you can take it down. Then this conductivity In terms of relaxation time, it is given by n e square tau divided by m. Correct? So if you want to write it for resistivity ಏನಾಗುತ್ತೆ m upon n e square tau ಆಗುತ್ತೆ. So ಇದ್ರದ್ದು reciprocal ಅಂದಾಗ it will be n e square tau upon m. N is number of electron, E is the charge of the electron, tau is relaxation time, m is the mass. Okay, so take down these formulas also, which will help us for the derivation. Numericals. So either ನಂತರ resistance in series, resistance in parallel ಬರುತ್ತೆ. But according to the present academic year, it is deleted. So CET ಗುನು delete ಆಗಿದೆ ಅಂತಂದ್ರೆ most probably ಬರ್ಲಿಕ್ಕಿಲ್ಲ. Okay, so next concept after this, cells study ಮಾಡ್ತೀವಿ. That is cells in series, cells in parallel. Then meter bridge potentiometer ಕೂಡ delete ಆಗಿದೆ. Then next class we are having cells in series, cells in parallel. Two small derivations ಬರುತ್ತೆ, which will end the. In the next class we will continue with the last part and the MCQs. Okay, students. Thank you. I hope you understood. There is no doubt for today's class. If anything is there, you can tell. Okay. We will continue with the next week, Wednesday class. Thank you. We will take one exam, okay? NEET students. So PCB one exam madana. We will announce the date. Monday we will announce the date for you, because already allowed one do lessons complete agide already. We will conduct one PCB test. First lesson mele. So physics first lesson ನಾನು ನಿಮ್ಗೆ already topic ಹೇಳ್ತೀನಿ. First lesson you prepare ಮಾಡ್ಲಿಕ್ಕೆ start ಮಾಡಿ. Whatever the MCQs we have covered, theory ನಿಮ್ಮ ಹತ್ರ already ಇರುತ್ತೆ. So please go through it. Yes, thank you.